Hello friends, welcome to one more video on Java 8 new features. So in this video we will be covering another predefined functional interface called function. So in the last video we have understood how a predicate, what is a predicate and what is the method available in the predicate, and how can we use that predicate in our real-time examples. So in this video, we will try to understand about function. See, function is also a functional interface which has only one method called apply method, and this method can take only one argument of any valid data type and can return any valid data type of Java. So its signature will be like this. See, @ functional interface public interface. It will take public interface function, and here we need to pass two parameters, generic parameters. So first one represents the input type and second one represents the return type, and it has only one method called as apply method, which will take one argument. So this is the signature of the function in interface. So this interface can be used, say, wherever we need a kind of a function, say, which will accept one data type and returns a kind of value after processing. So in that scenarios, instead of writing our own method and writing that inside a class and creating an object, then we can directly use this. Now let us see, without this, if I want to calculate the factorial of a number, and by passing the value to it, it will return the factorial of a number. So how do I implement that? Usually, so we have to define one class, right? Say I am defining one class called utils. Here it is, I am having one method called public int, say fact int n, right? Int n here. Say I am looking at very simplest case, right? Say for I is equal to, right, int I is equal to 1, I less than or equal to n, I plus plus, and every time f equal to f star I. Then finally if you return this f, then you defined it. So now how do I call this? We have to first create one method or one object, right? Say u equal to new utils, and then you need to call, right, say system dot out dot println. If I say u dot fact of 3, then this will return you the factorial of 3, like 6. Say in the same way, if I say system dot out dot println u dot fact of 4, right, then this will return you a 24, like this. So if you observe here, say for one single method which I need, say I have to write it inside a class and create the object for that class, and then call the method. So this is the traditional way. So now how can I achieve this? By using this functional interface called function. Now first of all, when I want to use this, we need to understand what is the signature of the method that we are going to implement. So this method is taking one parameter, one integer parameter as its argument, and return type is also integer. So this is in accordance with my signature of the function. So it is taking one input parameter and can return any type. So now we can implement this by using the function interface. So again, how do I need to implement this? So we have to define first whatever the method that we have must be in a lambda expression first. So now if I want to represent this in the form of a lambda expression, say how would I do that, right? Say as we know, lambda expression doesn't have any name, access modifier and return type. So it will simply, let us say, n equal to. Now this is having more than one line. So you can simply write exactly whatever is there, you can simply write it in the body. So this is my lambda expression. So this is a lambda expression here. so which is equivalent to this method. So now this lambda expression will be assigned to this functional interface so that we can call this apply method to get it. So how do we do that? Now see here, I'll use the function, right? Say how do I call that? Say function, and we have to pass the input type and return type. So in this case, input type is also integer and return type is also integer. So let us say a function, I am calling the function object as f, and which is equal to my lambda expression, right? Say the total lambda expression whatever we have, so we can apply like this. So in this case, what the function will do, if I call this f, see internally in the f we have only one method called apply. So exactly what we did here, right? Say here, if I call this not fact here, right? Say we have to call the apply method, right? Because functional interface which is having only one abstract method called apply. So if I say f dot apply, then this will also return the same value. So similarly, right, if I call this method by means of by passing this 5, then it will return 120. So like this we can call this, right? We can call this function interface to implement this kind of features of the methods. Let us look this in action. I'll create one simple class. So this class is, say, function example with public static void main. So I will make use of the same thing, right? So let us define the same method here. So our function, we know, right? Say this function is available in java.util.function package. So now if you observe here, say we have just we have just mentioned the lambda expression, assigned the lambda expression to this function. So now next is very simple, right? Just write the same thing, just write the same thing here after this lambda expression. If I say this f dot apply here, then if you run this one, you can see the factorial is 6 and the 5 factorial is 120, right? Obviously, so it will be 120 only. So you can simply run this. So this is how you can simply implement a function. Let us take one more example. So where I want to calculate the say simple area of a circle, right? Area of a circle by accepting the radius and return the double value. That is, the area of a circle is calculated with pi r square. Now the same thing we can implement by using the same functional interface. So how do I write that? Say function input type is integer because radius I will give it as an integer, and return type is double. So because area 3.14 decimal number, right? So I am getting it as double. So I'll create object called f2. So how do the radius is calculated? If I pass the radius as input, then 3.141 star radius simple, right? 3 point. So this will be returned whenever you pass this. So how do I call this again on the F2? Again we need to call on the same apply method by passing the value to it. Now if I say system.out.println, see the area of a circle with 5 radius is, right? With 5 radius is, say f2 dot apply of 5, right? So when you pass this, when you call this method f2 apply of 5, so this 5 will be copied to this radius and it will calculate this and returns the total value to this called place. So exactly in the same way, when I call this f dot apply of 3, so this 3 will be copied to this n and it will perform the method, that is your factorial, by iterating from 1 to 3. f1 every time f1 equal to, so it will return it. So like this you will able to implement it. Right now you can see area of a circle, right? Area of a circle with radius 5 is 78.25. So in this way you can also do that. So let me define two more functions. Let us say I have a function integer and integer. So I am defining one more variable called say f3, right? F3 equal to, if I pass some n value, then I will be calculating the square. In the same way, let me take one more function f4. Say if I pass n, then it is 2 times n, right? So now if I call this system dot out dot println f3 dot apply of 2. In the same way, system dot out dot println f4 dot apply of 2 or 3, anything. So what would be the output for this one? Say when I pass the value of 2, this will be 2 square, that is 4. So in this case, when I pass the value of 3, because it is f4, f4 is actually calculating 3 into 2, that is 6. So these are my expected outputs. So you can see here. So first one is 4 and second one is 6. See, just like our predicate, we can combine two or more methods. Here also we can combine two or more methods in it. See, previously in the predicate, the combination is with and or, right? Say with both the conditions are true, what would be the resultant condition? If any one of the condition is false, what would be the resultant condition? Like that we have implemented and or. But here this is not a condition, right? It is a value. So here again we can combine two or more predicates by using two conjunction operators called as and then is one method and compose is another method. And then and compose is another method. See here and then and compose will try to implement the order in which these methods are called. See, if you see f3 and f4, if I first call f3 and on the result if I call f4, then the result will be one thing. If I first call f4 and then if I call later f3, then the result will be different. For example, take the value of 2. If I first call f3, right? If I call f3, so for the 2, right, say f of 2, so this will give you the value of 2 square, that is 4. And if I pass this on 4, then 4 into 2 would be 8. Similarly, first if I call this, right, say if I call this first f4 of 2. So f4 of 2 means 2 into 4, 8. And if I pass this, right, then to f3 of 8, then this is 8 square, it will be 64. So if I call first f3 and then f4, it will be 8. And if I call f4 first and then if I call f3, then it will be 64. So this, the way, the order in which you want to call is identified by using and then and compose. Say and then will try to call the left hand side method first, on the result will be applied to the right hand side method, and compose will make first right hand side method will be called and the result will be passed to the left hand side method. So now the same example, if you see here, system dot out dot println, say f3 dot and then of f4 dot apply of 2. So first what this method will do, first f2 will be applied to, sorry, 2 will be applied to f3 and the result is applied to f4. So for this case we would be expecting the value as 8, right? So in the same way, if I say f3 dot compose of f4 dot apply of same 2. F3 dot compose of F4 dot apply of same 2. So what this will be done? First F4 is calculated and the result is passed to F3. So as usual, this we will expect a value of 64. No, sorry. Say first F4. F4 means 4 twos are 8. So where is my value? Yeah, 16. So now you can see first one is 8 and second one is 16. So like this, your function can be called and used in our expressions. Hope you understood this function. We'll see you in the next video with another functional interface. Thank you.